before spring break, right, we learned what a polynomial function is. Put this one up, my notes up here instead. Okay. A polynomial function, right, is a sum and difference of monomials, right? And monomials, right, are just power functions of x to the k power, where k is a positive integer. Okay. So we gave these two examples last time, right? These are not polynomial functions, because in the first case, the exponent on the variable x is negative. In the second case, the exponent of the variable x is not an integer. Okay. But these guys down here, these are examples of polynomial functions, right? You'll notice that the exponent on the variable x in each term is a positive integer. Okay. And then we learned what the behavior of a polynomial function is like. Okay. On each end in the graph of a polynomial function, the graph is either going to go up or it's going to go down. Okay. That's true on the left end and true on the right end, right? It's either going to go up or it's going to go down. And whether the graph goes up or down is determined by the leading term in the polynomial. And the leading term, right, is the term with the largest power of x. So in this notation, a sub n times x to the nth power is the leading term. So that term determines whether the graph goes up or goes down on each end. Okay? And that's where we ended on Friday before spring break. Okay? So you flip over your paper. Page 2. Pick it up there. I got my booster shot over the break. I did get that done. So now I'm feeling invincible. And now I wish they'll do away with the math requirements altogether. Okay. I'm hoping that happens. That we don't have to do this until the end of the semester. Or we can finally get to the point we don't have to wear masks in the class. All right. So top of page 2, it talks about what a turning point is. So I'm just going to graph an arbitrary polynomial function. So don't ask me where I got it. It's arbitrary. I'm just making it up. Okay. So that, and graphs of polynomial functions tend to be smooth hills and valleys, or they're smooth curves. So I view this as a hill, and this as a valley. Okay. And the points at the top of the hills and the bottom of the hills are what are called turning points. Okay. So this is a turning point, that's a turning point, that's a turning point. Right? We're going from uphill to downhill at this turning point. At this turning point, we're going from downhill to uphill. And at this turning point, we're going from uphill to downhill. Okay. So turning points are just the tops and bottoms of hills. Okay. So in example 2 says use the zeros and the end behavior of the polynomial function to sketch an approximation to the graph of the function. Okay. Well, use the zeros. What are zeros? So let's define what zeros are. And we're going to be using this term from now until the end of the semester. So it's important that you understand what we mean by the zeros of a function. Okay. And the zeros are the x-intercepts of a function. And those occur at values of x that make f of x equal to 0. Right? Make the value of the function equal to 0. Okay. The graph crosses or touches these axes at each one of its zeros. Okay? So I didn't draw any on this polynomial function over here. But here, let me graph another one. Except this one crosses and touches the x-axis, right? So here it crosses the x-axis, here it crosses the x-axis, here it crosses the x-axis. You know that where it crosses, where it touches the x-axis, that's an x-intercept, right? And that value of x, that value of x makes the value of the function equal to 0. And so those values of x are also called zeros of the function. Okay? So x-intercepts are the zeros of f of x. They have a dual meaning. Okay? Where it crosses the x-axis, those values of x where it crosses and touches the x-axis are also the zeros of the function, because when you plug that number of x, that number in for x, f of x equals 0. Okay? The value of the function is 0. Okay? So in A, we have the function f of x is equal to minus x cubed plus 4x. Okay. So we got to use the zeros and the in behavior of the polynomial function to sketch an approximation to the graph of the function. Okay. Right. This is a polynomial degree 3, right? The largest power of x is 3, and so you can see the leading term of this polynomial function is minus x cubed. And from that leading term, we can determine whether the right end of the graph goes up or down, or whether the left end goes up or down. Okay. So, remind ourselves, minus x cubed is the same as minus 1 times x cubed. So minus 1 is the leading coefficient, and minus 1 times x cubed is the leading term. Well, when the leading coefficient is negative and the degree is odd, does the right end go up or does the right end go down? Do you remember? You always got a 50-50 chance of guessing correctly, right? On each end.
I believe the right end goes down.
Yes, that's correct. The right end goes down. Okay. What about the left end? It goes up. So when the degree is odd, remember each end's going to go in the opposite direction. If the degree is even, they both go up or they both go down. Okay. Yeah. So left end's going to go up and the right end's going to go down. Okay. So now we can find the zeros of this function. And to do that, right, we got to find the values of x that make the right-hand side equal to 0. And so we do that by factoring the right-hand side. Okay? And we can factor out a minus x, and when we factor out, right, because x is common, right, you got two terms. Both terms have x in it. The lowest power of x is x to the first, so we can factor out x to the first. But because of this minus sign here, I'm going to factor out a minus x. Okay. And when we do that, we have minus x times x squared minus 4 in parentheses. Minus x times x squared is minus x cubed. And minus x times minus 4 is plus 4x. And now you can see x squared minus 4 is a difference of squares. It factors. it factors into x plus 2 times x minus 2. So now we have the product of three factors. Okay. And to find the zeros, we set the right-hand side equal to 0 and solve for x, right? Using the zero product problem. To find the values of x that make the right-hand side equal to 0, that make f of x equal to 0. So we have minus x times x plus 2 times x minus 2 is equal to 0. And so now we set each of those factors equal to 0 and solve for x. So we have minus x is equal to 0. X plus 2 is equal to 0. X minus 2 is equal to 0. Right, but the 0 product property. So the three values of x that make f of x equal to 0 are x equals 0, x equals minus 2, and x equals plus 2. So that's also the location of the x-intercepts. Okay. So now we can get a crude graph of this polynomial function. There's going to be an x-intercept here at x equals minus 2, one at the origin, and one at x equals plus 2, right? We already determined that the left end goes down. So from this x-intercept, the graph must go down. Okay. And it can't turn around and go back up or cross the x-axis again and create another x-intercept. And from this x-intercept, minus 2, it's got to go up. And so since it crosses, right, so it's got to cross here, go through the origin, create a turning point, and then come back down again. And so that's a crude graph of that polynomial function. Okay. These are x equals minus 2, x equals 0, x equals 2 are the three zeros of the polynomial function, which is also the location of the three x-intercepts. And from the leading term, we determine that the graph of the polynomial function goes up on the left and down on the right. And so from that information, we can get a crude graph, crude sketch of this polynomial function. Okay. Any questions on that? Okay. All right, let's take a look at B. In B, we have f of x is equal to x to the fourth minus 5x squared plus 4. Okay. Well, the leading term is the term with the largest power of x. In this case, it's x to the fourth. And the leading coefficient is the invisible 1, right, in front of x to the fourth. So leading coefficient is positive and the degree is even. So on the right end, is the graph going to go up or go down? What about the left end? If the degree is even, it's like a polynomial, it's not like a parabola that either goes up or goes down. And when the leading coefficient is positive, the two ends are like that of a parabola. Right? Both ends go up. Okay. A parabola that opens up. Okay. So now we know that. Now we got to find the zeros. Okay. The x-intercepts. Well, this is a complicated, right? This isn't a quadratic, but it factors like a quadratic. It factors into x squared minus 4 times x squared minus 1. You notice that the powers of x are 4, 2, and 0. So when you multiply first terms, you have x squared times x squared, which is x to the 4th. And when you do the inner, you get minus 4x squared. When you do the outer, you get minus x squared. Minus 4x squared minus x squared is minus 5x squared. And then when you multiply last terms, you have minus 4 times minus 1, which is plus 4. Okay. So this is a case where you can factor a 4th degree polynomial kind of like you would a quadratic. And now you can see x squared minus 4 is a difference of squares, it factors. And x squared minus 1 is a difference of squares, it factors. X squared minus 4 factors into x plus 2 times x minus 2. And x squared minus 1 factors into x plus 1 times x minus 1. And now we set the right-hand side equal to 0 and apply the zero product property. When we set the right-hand side equal to 0, we have a product of 4 factors that's equal to 0. So one of those factors has to equal 0 by the zero product property. Either x plus 2 is equal to 0, or x minus 2 is equal to 0, or x plus 1 is equal to 0, or x minus 1 is equal to 0. Where the zero product property. So solving each equation, we get x equals minus 2, x equals 2, x equals minus 1, and x equals 1 are the zeros for this polynomial function. It's where the graph crosses or touches the x-axis. Well, so let's plot the x-intercepts. They're at minus 2, minus 1, 0, minus 2, minus 1, none at 0. X equals 1, and x equals plus 2. Now we know on the right end and the left end, the graph goes up. So at x equals 2, right? Graph crosses at x equals 2 and goes up forever. And at x equals minus 2, right? The graph crosses the x-axis and goes up forever. So, and minus 1 is an x-intercept. So the graph's got to come down, form a turning point, and then go up and cross the x-axis. And over here, going from right to left, the graph crosses the x-axis, forms a turning point, and then goes up. Now the graph is going to cross the y-axis somewhere. Okay? We can actually calculate the y-intercept. Right? Replace f of x with y, put 0 in for x, and you get y is equal to 4 is the y-intercept. So here up here at y equals 4, the graph crosses the y-axis. Right? Remember how to find the y-intercept. You set x equal to 0 on the right-hand side. Solve for y. So we replace f of x with y, put 0 for x, and we end up y is equal to 4. It's the y-intercept. And there's our picture. Okay? There's our sketch of this polynomial function. Okay? Based upon the in behavior and the zeros of the polynomial function. Okay. All right. Any questions on this? Okay. In example 3, a little bit more challenging problem. Find a polynomial function with leading coefficient equal to 2 and zeros -3, -1, 3, and 4. So the zeros are x equals -3, x equals -1, x equals 3, and x equals 4. Now we're going to do something in reverse. Over here, right, we start with the polynomial function. We factored, set the right-hand side equal to 0, applied the zero product property to get the zeros of the polynomial function. Here we're given the zeros of the polynomial function, and now we're going to go backwards and write the function, right, as a product of factors. So if these are the zeros, then to get the factors, we just, right, move the number on the right-hand side to the left-hand side by addition or subtraction, make it equal to 0, and then what's on the left-hand side is a factor of the polynomial function. So, putting 0 on the right-hand side of each of these equations, right, this first one I add 3 to both sides, and I get x plus 3 is equal to 0. This one I add 1 to both sides, I get x plus 1 is equal to 0. This one I subtract 3 from both sides, I get x minus 3 is equal to 0. And this one I subtract 4 from both sides, and I get x minus 4 is equal to 0. So I went over here, I went from this step to the previous step. And now I'm going to go from this step to this step, writing f of x as a product of factors. Okay. So we're going in reverse. Okay. So f of x leave a space out front after the equal sign, is equal to the product of these 4 factors. X plus 3 times x plus 1 times x minus 3 times x minus 4. We're not done with what f of x is equal to, because if we were to expand this, we'd have x times x, the leading term would be x times x times x times x, which is x to the 4th. But we're told polynomial function has a leading coefficient of 2. And so the leading term has to be 2 times x to the 4th. Right? 4th degree polynomial, 2 is the leading coefficient. So we have to multiply these 4 factors by the number 2 up front. Then the leading term will be 2 times x to the 4th. X times x times x times x is x to the 4th, and then times 2 gives us 2x to the 4th. Okay. So this factored, this is called a factored polynomial. Okay. Has these 4 zeros, right? Because if you set the right-hand side equal to 0 and solve for x, you get these 4 zeros. And it has 2 as a leading coefficient. Okay. If you expand this on the right-hand side, you end up with 2 times x to the 4th. That's the leading term. Okay. So this is the answer, right? Is there any questions on that? So this problem, we did this problem in reverse. Started off with the zeros, and then we had to work backwards to get f of x. All right. Any questions on that? All right, so now let's talk about multiplicities. In the examples that we've done so far on this page, all the zeros occurred only once. Okay. But now we're going to talk about the case where a 0 can occur multiple times. Okay. So the polynomial function f of x has a factor of the form x minus c to the k power, where k is an integer greater than 1. Then x equals c is what we call repeated 0, and we say it has multiplicity k. Okay. So in all our examples over here, right, the exponent on each of these factors is 1, and so none of these zeros are repeating zeros. Okay, they only occur once. But we're going to look at the case where we might have a factor of like x minus 3 to the 5th power. So x equals 3 is a 0, but it occurs 5 times. So we say x equals 3 is a 0 with a multiplicity of 5. Okay, that's what this is all about. Okay. So it says if k is even, then the graph flattens and just touches the x-axis at x equals c. So if k is even, then this is the x-axis. Then at that 0, the graph is either going to come from above the x-axis, come down and touch it, and then go back up, or from below, it's going to rise up and touch the x-axis and go back down. It won't cross the x-axis, it'll just touch it. Okay. If k is odd, then at the graph of the polynomial function at each 0, we either come up from the bottom and cross the x-axis going left to right, or it'll start from the top, cross the x-axis, and go down to the right. Okay? one of those, both, right, for each zero, okay, one of those four graphs is going to be true. Okay? And so if it's even, the graph is either going to touch the x-axis from above, or it's going to touch the x-axis from below. If k is odd, the graph's going to cross the x-axis at that zero, but it's either going to cross from below or from above. Okay. And so we can determine that. Okay. All right. So example 4. We're given two polynomial functions. Okay. One in standard form and one in factored form. So in the first one we have f of x is equal to x to the fourth minus 3x cubed plus 2x squared. And so this one's not difficult to factor. You can see we've got three terms in this polynomial. And x squared is the smallest power of x. So we can factor out an x squared from the right-hand side. So when we factor out x squared, we're left with x squared minus 3x plus 2 in parentheses. And then this quadratic in parentheses factors with integers. It factors into x minus 2 times x minus 1. So we went from a polynomial in standard form to a polynomial in factored form. Okay. Now, if I gave you this polynomial in factored form, you would know the leading term is x to the fourth, because x squared times x is x to the fourth. Okay. So now to find the zeros, right? We set each of these factors equal to 0 and solve for x, right? So we have x squared is equal to 0. X minus 2 is equal to 0. X minus 1 is equal to 0. And when we solve for x, we get x is equal to 0, x equals 2, and x equals 1. Those are the zeros of f of x, which are also the location of the x-intercepts in the graph of the polynomial function. Well, x equals 0 is a zero of multiplicity 2, right? X squared, so x equals 0 is a 0 twice, right? Because x squared can be written as x times x. So when he said that equal to 0, right, there are two locations you can put in 0 and for x. So x equals 0 is a 0 multiplicity 2. These other two guys have a multiplicity of 1. Because it's x minus 2 to the first power, x minus 1 to the first power. So the power on x minus 2 is 1, power on x minus 1 is 1. But the power on x is 2. So x equals 0 is a 0 of multiplicity 2, and x equals 2 and x equals 1 are zeros of multiplicity 1. Odd. So now we can graph this thing. Okay? X to the fourth is the leading term. So we know what the end behavior is. So zeros are x equals 0, x equals 1, and x equals 2. So with x to the fourth as the leading term, does the left end go up or down? Up. What about the right end? Yeah, both ends rise, right? Both ends rise. So here at x equals 0, the left end of the graph goes up. Okay. Now, and at x equals 2, to the right of x equals 2, the graph goes up, right? That we know. Well, x equals 0 has a multiplicity of 2. So does the graph cross at x equals 0 or touch at x equals 0 and turn around? Turns around, right? It's like this, because k is equal to 2. K is even. So the graph is going to come down, touch the x-axis, x equals 0, and then turn around and go back up again. But x equals 1 is a 0 with multiplicity 1. That's odd. What? 1 is odd. So the graph's going to cross at x equals 1. So the graph has got to form a turning point and then turn around and cross the x-axis at x equals 1. And x equals 2 is a 0 with multiplicity 1. So the graph has to cross at 2. So the graph's got to come down, form a turning point, and then come back up and cross at x equals 2. And that is the rough shape, rough sketch of that polynomial function, based upon the end behavior and the zeros, right? They're in their multiplicities. Any questions on that? Okay, let's take attendance.